Okay, welcome back to week 2, part 4. In the previous part, we took a look at programs and we talked about getting user input with the input function, and we also talked about type conversion among the low-level data types in Python, namely int, float, str, bool, and also the special value none. Here's the example program that we looked at. We use the input function to ask the user to enter their height in feet. Whatever the user types then is collected by the input function and passed as a return value in a string. And we had this variable feetster set to refer to that string that was returned. Now we can't do direct arithmetic computations on a string, so we then converted that string into a float number that we could successfully multiply by 12 to get the height of this person in inches. Okay, so if I press F5 to run this, as we saw, enter height in feet, 5.75, let's say, and height in inches is 69. In this final section for week 2, we're going to take a look at exceptions that can occur that will cause your program to crash. We're also going to introduce while loops, which is another form of loop in addition to the for loop we've already discussed. We're going to introduce defining and calling functions. If you have a chunk of code that you want to have executed over and over again, it's usually convenient and useful in terms of making the code reusable to put that code in a function. Finally, we're going to take a look at file input and output, which is something that you need to know how to do in addition to getting input from a user and producing output to a user. Okay. So let me get back to my shell. If you try to do something illegal, like 7 divided by 0, you get yelled at. This is a so-called exception, and this particular one is a zero division error. If you had that expression as part of a program that you were executing, the program would die at that point. It would not be able to continue on to the remaining code in the program. As another illustration, if I have a list of values, 3, 5, 7, 9 is this particular example, and I use a bad index. The indexes that are legal for M are either 0 through 3, going from the initial item to the last item, or -1 to -4 if I wanted to start from the last one and count down to the initial one. So M sub 5 is going to give me an error. This time it's called an index error. That, again, would crash my program if I had this expression in an overall program. Similar examples include if I tried to take a string that did not represent a valid int and converted that to an int, I would get an exception called a value error. And if I attempted to do something like dividing a string by an integer, division is not something that a string understands how to do. So 1234 over 5 gives me this type error, telling me that this is an unsupported operand for a string on the left side and an int on the right side. Any of these things, if you have them in your program, will cause your program to crash. Now, to protect yourself from exceptions, you can use something called a try block containing statements that you are concerned might fail. And if some statement in the try block does fail and generate an exception, you can use the word except at the conclusion of your try block to capture and deal with those failures so that your program does not crash. Okay, ordinarily when an exception occurs, your program just crashes. But by using a try block followed by an except, you can catch and deal with exceptions that occur. So let's take a look at, let me do this interactive one first, just for illustration purposes. So I'm setting this variable val to refer to 0.0, and then I'm going to try. Notice that I've got the keyword try with a colon after it, and the try block has to be indented, and every line in that, every statement in that try block has to be indented at the same level. I'm just going to do something right away that's obviously going to fail. I'm going to say val gets 7/0. Now, the shell has not started executing this yet because I haven't hit a blank line. I haven't entered a blank line yet. So I can keep going, and I can go back to the beginning of the line because I want to be at the same level as my try block, and I'll have my except part of the code to capture an exception that may occur. Definitely an exception is going to occur in this case when I do the divide by 0. And let me set val to a bogus value. Don't seem to be able to type. All right, so here we go. So I'm going to set val equal to minus 1.0 if this exception occurs. All right, well, the code in the try block was executed. That did cause an exception, but because I have the except chunk of code here, instead of crashing, the program simply, or the code simply, set the val variable to refer to -1. And I can confirm that by just looking at the value that val refers to. Okay, so in general, in Python programs, if you have reason to fear that some statement or some sequence of statements that you want to execute might cause an exception, then wrap the whole thing in a try block, and you can use except to handle any exceptions that occur. Now, there are more detailed ways of using except in a more sophisticated way, but we're going to satisfy ourselves for now with just this mechanism here. Okay, we've looked at the for loop. The for loop allows you to step through each item in a range of values. So I could say for x in, let's say 1, 2, 3, 5, 19, and I need my colon at the end, and then I can do whatever I want to with the current value of x for each statement within this for loop, or for each value of x. There are going to be 5 values for x as we go through this loop 5 times, and I'll just say something like x squared is x squared. All right, so there's the for loop that we have already seen. Now, the while loop is similar in the sense that it's a loop, but it's different in how the number of times you go through the loop is controlled. Instead of having an iterable to control the number of lines, the number of times that we go through the loop as we would in a for loop, instead, in the while loop, we have a Boolean expression that controls how long we, or whether we perform the statements within the while loop. If the value of that Boolean expression is true, then we will perform all of the statements indented within the body of this while loop. Very often, you'll have some kind of control variable whose value you check in the Boolean expression in the while loop. So here I'm going to say I gets 1, I is now referring to the value 1, and I will then type my while loop, while I is less than 10. Notice that I've got to have my colon to conclude that while loop syntax, just like a for loop or a try or an except or an if. In this while loop, I'm going to say print I followed by I squared followed by I cubed. If I hit the enter key now, I'm going to have a serious problem. Let me do this, and I'll probably have to close my shell, because if I just say while I is less than 10, display I squared, and I cubed, and I just have that be the body of my loop, this will run forever. This is what's called an infinite loop, because I's value is never changing. So I's value is never changing, meaning that I less than 10 is going to be true forever. And there we go. So I was just printing 1 forever. I wasn't sure that that would work, but I pressed Control C, and that did successfully interrupt the loop. And so now I regain control of my shell. So let me start again from I gets 1. And we'll say while I is less than or equal to 10. Oh, I forgot to say I. Okay, so I is 1. And while I is less than or equal to 10, print I squared, I cubed. And this time I'm going to be smart, and I'm going to add 1 to I as the final thing that I do inside the statement block contained within the while loop. All right, so I's initial value is 1, and I'm saying while I is less than 10, display I squared, and I cubed, then add 1 to I. So we'll run through first and just print out 1, 1, 1. We'll increase I to 2, and since 2 is still less than or equal to 10, we'll print out 2, 4, 8, and set I to 3. 3 is still less than 10, so we'll print out 3, 9, 27, and increase I to 4. Pretty soon I'm going to hit numbers that I don't know the cubes of right off the top of my head. So let's just hit the enter key here to let this run. Hit the enter key twice, and there we are. So here we have 1, 2, 1 up through 10 with the squares and the cubes of each of those numbers. I actually knew several of these, but I definitely didn't know that 7 cubed was 343. Okay, at least not off the top of my head. So the while loop is more flexible than the for loop in the sense that the while loop is not just controlled by going through some iterable, like a loop or a string or a range. On the other hand, the while loop is also more risky because it's easy to forget to change your loop variable at the bottom of the while loop and create for yourself this thing called an infinite loop that will just run forever until hopefully you can kill it off by pressing Control C. You may have to actually resort to closing your shell window entirely. So let's combine what we've talked about as far as the try block and exceptions and exception handlings and the while loop to take a look at how we can handle bad input from a user. Now, users are horrible things for a program to have to deal with because anything that you can possibly imagine a user doing incorrectly in your program will definitely happen, and even things that you can't conceive of, some user will do. Okay, users just make enormous numbers of errors of all imaginative types. So, and here's a sort of a general way for dealing with user input. We're going to call the input function with a prompt to get the user to type some input string. Then we're probably going to want to convert that into a number to use in computations. So we'll try to convert that to an int or a float. Now that might fail. Remember that if I try to convert hello into a float, that is an exception. Ordinarily, that exception would cause my program to crash. But we're going to be a little clever. We're going to do the conversion inside of a try, and we're going to have an except at the bottom of the try, so that if the user does type some bogus input that can't be converted correctly, we'll be able to capture that exception and display an error message for the user telling them to please try again. Now, even if the user does type a value that's correctly formatted so that the conversion works, it's possible that what the user types will have some kind of range errors. For example, if you ask someone to enter the number of apples that they bought, and they type in a -10, well, -10 might be correctly formatted as an integer, but it's nonsense in terms of being the number of apples that you might buy at the store. You're not gonna take 10 apples back to the store and claim that you bought -10 apples, or at least not in most grocery stores. Okay, so here is a little program called user age, in which we're going to make use of the while loop, try and except, and we're going to then do a range check to find out what some user's age is. And it seems like a lot of code to accomplish that little task. Let's go ahead and create a program file to contain this. So this will be a new file, and I need to shrink this down so that it fits. And I'm going to go ahead and, I'm going to go ahead and manually type this thing in so that we can talk about it as we go. All right. So I'm going to say file, user age, and I'm concerned that I may run out of space. I may have to decrease the font size. So I'm just also going to add up here author, me. We're going to ask the user to please enter their age. Then we're going to read their age and convert that age into a float so that we could do some computations involving that age. Now, the user can make all kinds of errors. So we're first going to set up a flag variable for ourselves that's eventually going to contain the correct user age. I shouldn't call that a flag variable. We're going to set up a variable to contain the user's correct age, but we're going to initialize that variable with a bogus value. Nobody talks about being a negative number of years old, so clearly -1.0 is not a valid age for a user to have. Now, while the age of the user is less than 0, actually, let's say less than or equal to 0. Okay, now in my example in the notes I have a less than, but actually having an age of 0 doesn't make any sense either. So while the age is less than or equal to 0, let us try to ask the user to enter their age. Enter your age. So the input function is going to display that prompt, enter your age. the user will type some input and press the enter key, and whatever input the user typed, whatever sequence of characters the user typed, is going to get pulled in and stored into that aged variable as a string. We want that to be a float, so we are then going to convert what the user typed, aged, into a float. Now, the input conceivably could fail if the user is running this program and the user closes the window, or the user presses Control-C to kill the program or something like that. Then the input function is in some sense going to fail, and the whole program will be over. We're not going to worry about trying to protect our program from those kinds of catastrophes. If the user wants to close the window or press Control-C, we're just going to let that happen. But if the user does make some other kind of typing mistake so that the age they type in is not valid, then this float conversion might fail. So we need, at exactly the same level as the try keyword, to have an except block, and we will display to the user bad age format. Now, this is okay, so programmers have problems with users because users make all kinds of mistakes. Users also have problems with programmers because programmers often provide really bad instructions or unfriendly information. So this is not a particularly friendly message. If they type in something that's incorrect, we say bad age format. Which isn't necessarily going to help the user figure out what they did wrong, but we want to keep our program relatively brief, so we'll live with that for the moment. If the user did type something that's badly formatted, then we're going to make sure that our age is still a bogus value. So we're going to, if the age got changed to, something like 1,000,000 or some kind of garbage or something, we're going to set the age back to -0 to make sure, we're going to set the age back to -1 to make sure that this while loop is still going to cycle through and ask again. All right, now, another possibility is that what the user typed was correctly formatted. In that case, if we ask the user to enter their age and they type something reasonable like, 28, and hit the enter key, then age is going to be the floating point value, 28.0. And because the input function and the float function both succeeded, we'll just skip over the except block. And now we need to validate that the age user typed makes sense. Most current scientific thinking about human ages, barring some terrific advance in medicine, which with any luck will happen really soon, the thinking is that human beings just run out at around 120 years old. So if you survive pneumonia, if you survive cancer, if you survive traffic accidents, if you survive all these other things, then you're probably not going to make it past 120 before you just, before everything basically just wears out all at once. So we're going to assume that if the user typed in something that is outside of the range from 0 to 125, that we're just not going to believe the user. All right, so if it's not the case that 0.0 is less than the age, which in turn is less than 125.0, let's look at this again. So we're testing whether the age is not in an acceptable range for human ages. So an acceptable age is any age that's greater than Okay, interesting. Yeah, no, no, this is exactly what I want. If the age is equal to 0, we're going to count that as a bad age, because nobody talks about, a newborn baby as being 0 old. You might be some number of minutes old or whatever, but 0 is not a valid human age. Certainly not valid for somebody who's able to type. So if the age is in this range, strictly greater than 0 and less than or equal to 125, that's fine. But if that's not the case, if it's not the case that the age is valid, we're going to complain to the user, and we're going to ask the user to enter a value in, and here again, because I'm short for space, I'm displaying a particularly unhelpful message for most normal people. I'm saying enter value in, and then we have this half open interval. The value has to be strictly greater than 0 and less than or equal to 125. If the age that they typed was validly formatted, but not within this valid range, we're again going to set the age variable to this negative value. All right, so how is this all going to work? We start out with the age being minus 1.0, and we're saying while the age is less than or equal to 0, that is, we haven't gotten a valid age yet, we're going to ask the user to enter their age, and then we're going to try to convert that to a float. If some formatting goes wrong, we'll complain about the formatting and reset the age to -1. If the formatting was okay, but the age is not in a valid range, we're going to tell the user what the valid range is, and again, set the age to -1. So this loop is going to run over and over and over and over again until the user types something that is in proper format to be converted to a float, and that is also within this valid range of ages. So when we're all done with this loop, when the loop finally terminates, we'll say age is, and then age. Now remember that this comma here in the print statement by default is going to cause a space to be displayed. So the format here will look reasonable. It will be age space is space and then whatever the user typed. Let me save this file, save as, and we're going to put this into our program file directory, and we're going to call this one user age. And the editor will attach the .py extension for me. Okay, so if you squint hard, you might be able to see that the name of this file is user age. And let me run it. So I'm going to press F5 to run this thing. Enter your age. Okay, no problem. I'm going to lie. 21. Okay, unfortunately, I'm not 21. But notice that I, as a user, typed something that seemed reasonable to me. I typed the words 20 and 1. Now, this float conversion function is not smart enough to understand how to convert words into numbers. So the whoops, wrong program. Let me close that program. I don't need this guy anymore. Okay, so when I type 21, the words 21, this conversion function fails. It produces an exception. So I drop into the accept part here, and I display bad age format, and I set the age to -1. And then when I get down to the if, -1 is not in this valid range, so I'm going to display this message: enter a value in the range strictly greater than 0 and less than or equal to 125. And then set the age to -1 again here. Now, why do I set the age to -1 there? Well, the user might have typed something like, maybe the user thinks they're Methuselah, and they type in a number, 1,000. Well, 1,000 is in a valid range. I'm sorry. 1,000 is a valid float. It's not in the valid range. But if I fail to set age to some value less than or equal to 0, when I get up to my while loop, that test will be true. That test will be false because 1,000 is not less than or equal to 0. And even though I have told the user to enter a value between 0 and 125, I'm going to come out of the while loop and display age is 1,000. All right, so that's why I'm setting the age to -1 here as well as here. This one resets age in the case of a formatting issue. This one resets age in the case of a value range issue. All right, so I'm back up now to the top of the loop. I typed something that was not validly formatted, so the formatting failed. I got told that it was a bad age format. I also got told what the correct range of values is, and now I'm back up here. -1 is certainly less than or equal to 0, so I'm back here. Enter your age. Okay, all right, so you're going to be a problem. All right, well, I am 156. Well, this time I didn't get complained about the format being bad, because 156 certainly can be converted to a float, except correctly. But I'm not within the reasonable range for human ages, so I'm being told to try again. Let's say, I'm getting annoyed now, so I'm going to say -12. That's still not in a valid range. Let's try 44. It's still a lie, but it's not bad. It's correctly formatted, and it is within the valid range, so the loop terminates, and I am told age is 44.0. Okay, so there's quite a bit of machinery going on in here in order to handle formatting problems as well as value range problems. And it's all contained within this while loop that's going to keep running and running and running and running until eventually the user types a valid age that is greater than 0. Alrighty, so that's that. Next up, we're going to take a look at defining functions. We were looking previously at converting Fahrenheit temperatures to Celsius temperatures, and we had a formula that we knew worked. We could say Fahrenheit gets, let's say something like 78.9, and print that well, rather than printing this variable fare, let me just basically copy and paste what's on this slide here, and we'll talk about what's going on. So I want to see on my screen. Now, we don't need to worry about the lack of indentation here, because I have this whole business inside of parentheses, and if I have a bunch of stuff in parentheses, Python doesn't get angry at me about splitting a logical line across two physical lines. All right, so what this print function is going to display is that 78.9 Fahrenheit is, then the result of this computation, and then the word Celsius. All right, so 78.9 Fahrenheit is 26.05555, etc. Celsius. Now, I might want to know a whole bunch of conversions. Let's say 43.2. I'd like to know as well. And so what I did there was I copied and pasted the same code again and then just changed 78.9 in two places to 43.2. And so now I have that 43.2 Fahrenheit is 6.22222 Celsius. And maybe I have a pretty cold day. At least for Pittsburgh, minus 12.5 would be considered quite cold. And that is minus 24.722 Celsius. Okay, well below freezing. Now, if this is a calculation and a message that I'm going to want to see, that I'm going to want to perform and going to want to display over and over again, it's a really poor idea to be doing all of this copying and pasting and modifying. If I paste this again and say, let's see, this time I want to find out what 100 degrees Fahrenheit is in Celsius. So I changed the 78.9 to 100. That doesn't seem quite right. 100 Fahrenheit is 26.0555. Well, what I forgot was I forgot to change 100 in both of the places where 78.9 occurred. This is an extraordinarily common way of introducing bugs into programs, is by copying and pasting a block of code and then making modifications in some places in the code, but forgetting to make corresponding modifications in other places. This is a very popular way of introducing errors into your program. So what we want to do to prevent this problem is to define a function that contains within it all of this behavior. The way we define a function in Python is to use the word def to start things out. Def means define a function. Then we specify the name we want our function to have. Now, the rules for function names is the same as the rules for variable names. Since I want my function to do a Fahrenheit to Celsius conversion, I'm going to call it F to C. Maybe I should have called it FAHR to CELS or something more long-winded, but just to keep things brief, F to C. Then, following the function name, between a pair of parenthesis characters, I can put in whatever values I want the function to be able to receive as so-called arguments. Now, all the F to C function needs to receive is the Fahrenheit temperature. And I'm going to just call that thing F. And then my colon, similarly to for loops, while loops, if decisions, try blocks, we need to conclude the introduction to our function definition with a colon. Inside the function definition, in this case, I want to return a computed value back to wherever this function is being called. So I will have a return keyword, and then my calculation. 5/9 of f minus 32.0. And there we are. So that is my function definition. When I pass in a value as f, what I will get back is the corresponding Celsius value. Now, I just noticed that I forgot to include my multiplication operator. So let's try this again. Define f2c. Well, let's just see what happens if I run it. f2c of 32. Okay, well, if I convert 32 to Celsius, that ought to be 0 degrees. Whoopsie. I'm getting this strange message. Int object is not callable. Sometimes the messages that you get may not make any sense to you. In this case, what it's complaining about is that 9 is being followed by a percent sign, and the percent sign, 9 is being followed by an open parenthesis, and the open parenthesis character is how you indicate that you're trying to call a function. But 9 is not a function. 9 is an integer. So that's where we're getting this error from. 9 followed by a parenthesis is attempting to call an integer as though it were a function, and that's not valid. So let's try this again. Define f2c of some value f to return 5/9 times f minus 32.0. That's going to work a lot better. F to c of 32 should give me a 0. F to c of, let's see, 212 degrees, that's boiling, so that should give me 100. And F to c of something like 75, that's a kind of pleasant temperature in Fahrenheit, and that corresponds to 23.888 in Celsius. If I want to use f to c in a function, I could set up, let's say, a variable containing my Fahrenheit temperature, 43.2, and say print that temperature Fahrenheit is, and then f2c of t and Celsius. Okay, now that statement is easy to execute over and over again. I can just change the value of t. So I can say t gets 32 and execute that print statement. 32 Fahrenheit is 0 Celsius. Set the value of t to 95, that's pretty warm. And do that print statement again. All right, 95 Fahrenheit is 35 Celsius. And so on and so forth. In fact, I can easily use something like a loop, a for loop, to step through a range of Fahrenheit temperatures and print out the corresponding Celsius temperature for each temperature in that range. So let me say for 4t in range. Now we're going to start pretty cold, so minus 40 degrees Fahrenheit. Even a Minnesotan like myself would agree that minus 40 is pretty cold. And 110 is pretty hot. And we'll go in 10-degree increments. So starting from minus 40, working our way up to actually the value less than 110. So the topmost value is going to be 100. What we'll do is to print t Fahrenheit is f2c of t Celsius. There we go. So we got this nice output showing us for Fahrenheit temperatures ranging in 10-degree intervals from minus 40 all the way up to 100 the corresponding Celsius temperature. Turns out that minus 40 Fahrenheit is equal to minus 40 Celsius. That's where the two temperature scales cross one another. Okay. So, anytime you find yourself in a situation where you're tempted to do some copying and pasting of code, take that as a hint that what you ought to do is to define yourself a function containing that code that you can then call with perhaps one or two or three arguments, modifying what the function does each time that it's called. All right, so we've talked about how to get input from a user by using the input function, and we've also talked about how to produce output for a user to read on the screen by using the print function. We also need to know how to be able to get input from text files on your system and how to store output into text files on your system. It's also possible in Python to read and write binary data in files, but we're not going to concern ourselves with that. We're going to stick to text files for this course. So here is a little program whose name is long, copy file open close .py. Let me get that file opened up. In my shell, I'm going to say file open, and then we'll go to the directory with our programs in it. I have gone ahead and typed this program in, so we can simply open the file. And there it is, copy file open close.py. And let me shrink the size so that it will fit within the recording window. Okay, I don't need it to be quite so wide. There we go. So now let's talk through what's going to happen when we run this program. Whoops. Where's my program? There's my program. Okay. Okay, well, when we run this program, this time we are trying to access information stored in a text file rather than reading information from the user. In order to gain access to a file on disk, we have to use the open built-in function in Python. Open is like print in the sense that it's built in and just available for you to use. As the first argument to print, pardon me, as the first argument to open, you specify the so-called path name of the file that you want to gain access to. And this is a made-up name here, /dir1/dir2/in.txt. Now on Windows, text files tend to have names ending in .txt. The extension doesn't really matter. All that really matters is that the file does actually contain text. Also in Windows, if you're going through directory levels, either in the command prompt using the cd command or using the file manager application, the convention in Windows is to use a backslash to separate levels in the directory tree. However, that causes a problem for Python because the backslash is used for things like the new line character or the horizontal tab character or various other special characters. So, conventionally, the easiest thing to do is to simply use forward slashes to separate the directory levels from each other, and Python is smart enough to cause that to be treated as whatever the correct directory separator character is for your system. If you're using Linux or Windows, pardon me, if you're using Linux or a Mac or some other flavor of Unix, then / is the natural key to use for separating directory levels. All right, so we will presume that there is some file named in.txt, which is 2 subdirectories down from the top level directory, or the so-called root directory. The next argument that we give is this string rt. And what that means is that we want to open the file so that we can read text from the file. Okay, so RT for read text. Now, the internal mechanisms for reading text are different from reading binary. So we want to say RT for reading text. Generally speaking, if we're on a Windows system or a Mac or a Unix system, most text files that we're going to be accessing will contain ASCII characters. That is the standard keyboard characters in an American English keyboard. Python is aware of various different character sets. The most widely used character set throughout the World Wide Web currently is a Unicode character set called UTF-8. The 8 means that there are 8 bits in each byte of each chunk of the character representation. And by design of UTF-8, it turns out that the ASCII character set is a direct subset of the UTF-8 character set. So we want to specify the encoding UTF-8. That's a keyword argument. And that will take care of being able to correctly open and access ASCII files, as well as any other UTF-8 encoded file. Now, so that takes care of our input file. Assuming that this file exists, and assuming that we do have access permission so that we can read from that file, this will, and assuming that the file does recognizably contain UTF-8 characters, the open function will succeed and return to me something called a file handle that I can use for gaining access to read text from that file. And out of lack of imagination, we're calling this fin for file in. Now, rather than displaying information on the user's screen, we want to store information into an output file. So again, we're using the open built-in function. We're specifying as our first argument the location and name where we want the output file to be written. And this time, instead of RT for read text, we're saying WT for write text. And once again, we're specifying our UTF-8 character encoding. Again, assuming that you have permission to create an output file in this directory location, this will give us back an output file handle. All right, now if either of these two opens fails, that will generate an exception and the whole program will crash. So we can only get down to this loop if both of the two open functions have succeeded. All right, and so we now have an input file successfully opened called fin and an output file successfully opened called fout. It turns out that a file is an iterable. And if we loop through an input file using a for loop, then each line of the input file is going to be read in one line at a time and put into whatever our loop variable is. Conventionally, if you're reading lines of text from a text file, it's often the case to use line as the name of the variable. But that's a detail. You could call it, X or abracadabra or cow or any other variable name that you like. But what we're saying here is that for each line in the input file, and then we've got a required colon here, we're not going to do anything fancy. We're simply going to write to the output file the line that we read in. So all this little program is doing is literally copying a file. Each line of input is read, and then that line of input is written out to the output file. When you are done reading input from the input file and writing output to the output file, you need to remember to close both the input file and the output file. Okay, write is a named method that you can use with output files, and close is a named method that you can use with either an input file or an output file, and you should close both. Now, in the case of the input file, the reason that we want to close that is so that if we open the file again later on in the same program, we'll be able to start reading that file again from the very top of the file once again. It turns out that as you read lines from the input file, there's an internal counter or pointer, if you will, that steps forward through the file as each line is read in. So that when the loop is finished, in the input file, that pointer or counter is at the end of the file. If I attempt to continue reading more information from that file, I won't be able to get any more information because I'm at the end of the file. It's as though you walk down a hallway to the wall at the end of the hallway, and then you keep trying to walk forward. Well, you're just bumping your head on the wall now because there's no more hallway there. So the same thing here is true with the input file. Once you get to the end of the input file, you're not going to be able to get any more input from that file. So we're going to close the input file so that later on, if we wish to open the file again, we will find ourselves back at the beginning of the file to process the input a second time. Now, the reason to make sure that you close the output file is that as you are writing information to the output file, often that output is buffered in memory for efficiency. That is, your program executes the statement fout.writeLine, but internally what that actually causes to have happen is for the operating system to receive that line with the understanding that that line should, at some efficient, convenient point in the future, be written out to the disk. If the program dies without having closed the file, it's possible that not all of the output that you thought you wrote into the file will actually be in the output file when you later look at the file. So explicitly closing the file tells the operating system, hey, I'm really done, so whatever you have left in memory that you haven't written out to the disk yet, it's time to write that out to the disk. So when you do a close, that means that everything will have been written out to the disk. And if you then look at the file on disk, it should contain everything that you wrote into it. All right, so that was a lot of words, but the process really is fairly straightforward. We're going to open a text file for reading. We're going to open another text file for writing. And then while we can get lines of input from the input file, we're going to write those lines to the output file. And when we're done, we're going to close both of those files. So all this program does, as I said, is to copy a file. We can modify what's going on in this loop here to do more sophisticated things. Like for each line that we read from the input file, we could, for example, count how many occurrences of the digit 1 occurs in that string. And we could save that information into the output file rather than just copying the line. So this loop here is typically more sophisticated with more statements than just what we've got here. All right. What's the most likely thing to do wrong? Well, the most likely thing to do wrong by far is to forget to close your files. If you're a relatively new programmer, it's really easy to remember to open the files, because if you don't open the files, absolutely nothing works. But it's harder to remember to close the files, because if you don't close the files, sometimes you get away with it. Sometimes things kind of seem to work. All right, so let's look at another version of this program that eliminates the necessity of closing the files explicitly. That is, this next version of the program will close the files automatically when we're done using the files. Okay, so here we go. So this one is named copyFileWith.py. And you'll notice that it's using this keyword with rather than the fin and fout variables being created by open. All right, so let's open this file, and then we'll take a look at it step by step. All right, so I have closed the previous program on slide 10, this copyFileOpenClose.py, and I have opened in my editor the file copyFileWith.py. Now, this program is accomplishing the same thing. In one way, it's slightly more complicated, but in another way, it's simpler. The way that it's more complicated is that instead of using the open function and assigning the result of the open to a variable, instead we're using the keyword with, and then we have our open function as before, but then the word as fin. Now, with is a little bit like an if, sort of. That is, it's a control construct in which the body of statements have to be indented at one level. So we're saying with opening this file for reading text as fin, now we're going to have a whole bunch of indented statements that are going to be able to access that fin input file. That's our input file. So the first statement that's indented in that with block is another with, because we need to gain access to our output file as well. So we have the same open for creating a file that we want to write text into, and that's going to be called fout. Indented within that with, we now have our for loop that is reading lines from the fin file and writing those lines to the fout file. Now, so we do have this indentation stuff that we have to do. But the cool thing is that closing of fin and fout will be done for you automatically as soon as you get to the statements following this outermost with. All right, well, actually, technically, this with contains a with, which contains a loop. As soon as this loop is done, the output file is going to be closed automatically. That concludes the inner with. When we get to the outer with, the input file will also be closed. This is a lot safer than remembering to type the fin.close and fout.close yourself. My rule, this is one of Ostland's laws, is that it's about 4 times as hard to remember to do 2 things correctly as it is to remember to just do 1 thing correctly. So you eliminate a lot of bugs by using with rather than using rather than not using the with and requiring yourself to remember to use the close functions. All right, well, that gets us to the conclusion of this section. And in the lab, you'll get a chance to try out some exception handling. You'll get a chance to play with while loops a little bit, as well as defining and calling functions, and also reading input from a file and writing output to a file. And we'll get back together for week 3, part 1 next.